Hi folks, welcome to my YouTube channel. In this video, I'm going to look at the alkanes, but specifically the branched alkane. The alkanes that we look at, if you still remember, it was a straight alkane, right? They were straight, but now we're going to look at the alkane that has branches, right? Branches like a tree. Or a three, like a tree, right? That one, it was just a straight. Now this one, it has branches. Now the branches here, we have different names of that. We call them its alkyl group, or we call them branches, or we call them side chain. It was a straight chain in the previous video. Now this straight chain, now it has what? Side chains or branches, right? Now there are names of branches that you need to understand, guys. That when a branch has one carbon, we call it, it's what? It's a methyl. All right, and when a branch has two carbons, we call it, it's an ethyl. It's the same as the stem names that I show you. One, it's meth. It was meth, but now since it's a branch, we call it, it's a methyl. We put the YL. Now two, it's eth, but now since it's a branch, it's gonna be ethyl, and then propyl. But we're gonna focus on these ones mainly, guys. 3, it's propyl, and 4, butyl, but we're going to focus on these two only here. The propyl and the butyl later when we're doing the esterification, right? Now let's look at examples here. Let's look at an example. Guys, if you see this compound, if it was only these 3 carbons, right, and there was no this CH3 here, we're going to say it's a straight chain. Now this one, it's a branched chain, and this one is a branched alkane. So this is a stem and this is a what? A branch, right? This is a branch alkane. So when you name here, need to consider this, that this one is a what? Is a branch. We call it, it's one carbon, we call it as what? It's methyl. It's that CH3. This is a CH3, it's methyl, it's a branch, right? So when you name here, you need to first count the number of carbons in the stem. 1, 2, 3. Do you see the number of carbons in the stem? There are 3. That means if there are 3, that means our parent or our stem name, it's gonna be what? It's gonna be prop. 3 means prop, if you still remember. Prop means 3, right? It's gonna be prop 3, right? So now when you have a branch, guys, this is a rule, it's very important. When you have a branch, you start name the branch. In your name, you start with the branch. So our branch here, it's what? It's methyl, but you need to state where is methyl, right? So guys, this is going to be what? Carbon 1, carbon 2, carbon 3. If you see the branch here, it's in the middle, so it will be always in carbon 1, it will be always in carbon 2. Do you see? So it's 1, 2, 3. So this will be carbon 2, even if you say 1, 2, 3. So you're counting from left to right, the number of carbons, it doesn't matter, it will be carbon 2. So you need to state, as I've mentioned, that you need to state where is the branch. It's in carbon 2. So you say 2. Now you're going to say 2 what? 2 methyl, but to say 2, you can't just say 2 methyl. You have to say 2 dash what? Methyl, right? Here in the organic chemistry, you need to separate the number and the letter by a what? A dash, which is a hyphen. So it's 2 methyl. This is stating the address. Where is the methyl? It's in carbon 2. 1, 2, 3. 1, 2, 3. So we can count it any side, guys, any side, because the branch, it's in the middle, right? It's in the middle. It's not close to this side, it's not close to this side. So this can be 1, can be 1, can be 2, can be 2, in whatever side. So it's 2 methyl what? And the parent here, it's 3 carbons. It's 3 carbons, so it's going to be what? Propyl. propane. It's 2-methyl propane. It must be one word, no gap in between. So the name of this, it's 2-methyl propane, because this is propane, but it has the what? The methyl, which is the branch. Now let's do the condensed structural formula for this. So we're gonna start it from left. If you look at it from left, it's CH3, right? So we're gonna say CH3, and then we say bond, and then if you look at here, there's a CH, so I'll say CH, and then in this CH, in this carbon, there's a branch there, which is the CH3. So I'll show the branch and say CH3, right? And then C, and then this is what? This is what? CH3. So I'll say CH3. I hope I make sense. Alternatively, I can do this and say CH3, and say CH, and then open brackets and say CH3 and CH3. Okay, when you read this, that means it's a CH3, this one, and then the CH, which is this one. And then in this CH, which is in this carbon, there's a branch, which is the CH3. You want to have the CH3 in the middle. Once you have the CH3 in the middle of the chain, that means that this is a branch, like this. But you put it in brackets there, and then the CH3 there, right? Guys, I'm not gonna do all of them. The molecular formula. The molecular formula for this, you count the number of carbons. It's 4. It's 4 carbons. 1, 2, 3, 4. And the hydrogens, it's 3, 6, 8, 10. No, 3, 6, 9, 10. Right? 3, 6, 9, 10. So it's CH4, 10. Right, let's go to the next one, guys. If you look at this one, guys, you need to be careful now. You need to count the longest chain of carbon. Even here, guys, the parent here, it was 3, which is the parent is this one. It was prop, which is the stem. It was 1, 2, 3. It can be 1, 2, 3, or 1, 2, 3, or yeah, it can be 1, 2, 3, 1, 2, 3. Or 1, 2, 3, the one that we used. So even if, let's say, we used this, so this is going to be 1, 2, 3. So this is still 2. So, okay. So, guys, let's look at this one. Let's look at this one. So the first thing that you do here, guys, you count the longest chain of carbon. The longest chain of carbon. So the longest chain of carbon is going to be 1, 2, 3, 4, right? Or you can say 1, 2, 3, 4. So it cannot be 1, 2, 3. That's the shortest chain. So the longest chain of carbon here, it's what? It's 4 this way or 4 this way. So we can use this as a parent, or we can use this as a parent. Let's take the easy one. Let's take the easy one. So this is our longest chain, which is our parent chain, right? So now, if you're looking at the ends of this carbon, you have this end and this end of this parent chain, or the stem, right? So having this, you look at the branch. We have the branch there. Very important to know your branch. Your branch there is what? Is methyl, right? Which is the CH3. The CH3, you check, is it closer to this end or to this end? So it's closer. You see here, it's 1, 2. It's in carbon 2 from this side. From this side, it's what? It's 1, 2, 3. So it's closer to this side. So since it's closer to this side, so we'll say this will make this what? Carbon 1, carbon 2, carbon 3, carbon 4, right? So this means that this branch, it's in carbon 2. That's the address of it. It's located in carbon 2. So when we name the branch alkyl, this one, it's a branch alkane. So it's a branch alkane. So when you name, you start with the branch. Where is it? It's in carbon 2. So you will say 2 dash what? Methyl. So you mean by methyl, it's in carbon 2. And then your longest chain, your parent here, it's what? It's a bute, because it's 4. 1, 2, 3, 4. So it's gonna be what? Bute. And then since it's an alkane and no double bond, no triple bond, you'll say A and E. So the name of this one is 2-methylbutane. And then the condensed structure, it's CH3 and then CH, and then in that C there's a CH3 and CH2CH3. So it's gonna be CH3, and then you say CH. In this CH there's a what? There's a CH3, which is this CH3, right? And then there's a what? There's a CH2 and the CH3. So there's a CH2 and the CH3, right? I hope I make sense. The molecular formula, it's gonna be what? How many carbons there? It's 5, and the hydrogens it's 3, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12, right? Okay, let's go to the next one, guys. I'm not gonna do now I'm not gonna do the molecular formula in the next one. So let's look at this one. Let's look at the longest chain of carbon, the longest straight chain. It doesn't have to be straight, but it has to be the longest carbon chain. 1, 2, 3, right? Or we can go this way. 1, 2, 3. 1, 2, 3. 1, 2, 3. Or we can say 1, 2, 3. So in all what we do, the longest here, the longest is the 3 carbons. So let's take this as a parent, or we can take this as a parent. It doesn't matter. We take this as a parent, or this as a parent, or this is a parent. It doesn't matter. It's 3 carbons, and this carbon will be always 2. So let's take this one. So let's take that as a parent. So we have 2 branches here. If you notice, this is our parent, this is our parent chain, which is our stem. Now we have branches, this one and that one. It's 2 methyls there. So we have what? A methyl there, we have a methyl there, and we have another methyl. We have 2 branches. So you need to state you have 2 branches there, right? Don't let us assume. So the name of this one. Now, before, we need to know, in this chain, are these branches closer to which end? These branches are closer to which end? So we have this end and this end. Are these 2 branches closer to this end or closer? Both of them, they are not close to any end. They are in the middle. So we can say this one is carbon 1, carbon 2, carbon 3, or we can say carbon 1, carbon 2, carbon 3, doesn't matter. So where they are allocated in carbon 2. So even if you said this was your stem, so it's going to be 1, 2, 3, or 1, 2, 3. Do you see? This will be always carbon 2. Even if your stem was this, so it will be 1, 2, 3, or 1, 2, 3, right? So the name of this one, we start with the branches. It's 2-methyl. They're both allocated in 2 and 2. So it's going to be 2, 2. Right, and dash. And then since there are 2-methyl, you need to say di. Di means 2, right? And di what? Dimethyl. That means there are 2-methyl. Where they allocated in carbon 2, and another one is in carbon 2. It's 2 of them. And then the parent here, it's 1, 2, 3. Remember, we said that the parent is this one. That means it's what? It's prop. And there's no double bond here. So it's going to be what? Prop, and what? No double bond, no triple bond. It's 2-methylpropane. So the condensed structural formula here is going to be CH3, which is this part, right? And then we have the what? And the C, and then the C is connected with the CH3 and CH3. So we can say C, and then we have the CH3, CH3, and then we have another CH3 there. So CH3. So in this case here, our branches, right? So, and that's it. I'm not gonna do the molecular formula. It's quite easy. Now let's look at this one. This one, let's look at the longest chain. Let's count the longest chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. That's not the longest. The longest is still 7. 1, 2, 3, 4. That's not the longest. 1, 2, 3, 4, 5, 6. Or we can say 1, 2, 3, 4, 5, 6. It's not the longest. 1, 2, 3, 4. It's not the longest. So the longest is this one. It's 7. 1, 2, 3, 4, 5, 6, 7. So the longest is 7. So in this longest chain that we have two branches. We have this branch, which is what? It's methyl. And this one is what? It's methyl. Right? We have two branches. But in these branches, you need to be careful and check where are they close to. Are they close to this end or to this end? So let's look at this branch. 1, 2, 3. So this methyl is in carbon 3. Let's look at this one. 1, 2, 3. So in this one is in carbon 3 from this side. So both of these branches, they are 3 carbon away from the end. 3 carbon away, 3 carbon away from the end. So it doesn't matter which one. This one is going to be 1, 2, 3, 4, 5, 6. Doesn't matter. So we can say here, this will be carbon 1, 2, 3, 4, 5, 6, 7. Or we can say this is carbon 1, 2, 3, 4, 5, 6, 7. It doesn't matter because there are 3 carbon away from the end, right? So let's say we take this one, right? We take this one. So the first carbon is going to be what? It's going to be at 3, and the other is going to be at what? 5. Let's say we take this side, not the purple one. Take the white one. So from left to right, it's going to be 3 and 5. Let's say if we were taking this side to show you that it doesn't matter. So it's 3 and 5 if we're taking the purple, so it doesn't matter. So we're going to start with the branches and say 3, 5 and di, because there are 2 of them. Di what? Methyl. So there are 2 methyl, the other one is 3, and the other one is at 5, and then dash and di means 2 of them, and then dimethyl. And the parent name is 7, so it's going to be what? It's going to be hept. 7, it's hept, and then this is an alkane, and no double bond, no triple bond, so it's going to be 3,5 dimethyl heptane. It's an alkane. All right, guys, I'm gonna leave the condensed structural formula just to save time. I'm going to focus on the names now. So let's look at this one. In this one, let's count the parent. The longest chain is 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So it's 7 this way or 7 this way, right? It's 7, 7, right? So it doesn't matter which one you take. You can take this one or you can take this one as a parent. It doesn't matter. Let's stick to an easy one, that one. So our parent is going to be that one. So in this parent, you have this end and this end. So in these 2 ends, okay, I didn't finish that. There's supposed to be hydrogen there. So in this parent, you have this end and this end. So in these 2 ends, you check which branch is it close to. So if you have this parent, you have 2 branches, this one and that one. So you have a branch which is what? Methyl. And you have a branch. You need to spot your branches. Methyl. So you let's look at this methyl. 1, 2. This one is in carbon 2, and this one from this side, it's what? 1, 2, 3, 4. I mean, it's in carbon 4. No, yeah. So in this, guys, this will tell us which side is going to be carbon 1, right? This side. Because if you look at this branch, it's far from the end. This branch, it's closer to the end. So we will say this is carbon 1 since this branch is closer to this end. I hope that makes sense. So this will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, right? So do you see this branch? It's in carbon 2, which is closer to the end. From this side, this branch is in carbon 1, 2, 3, 4, right? It's in carbon 4 from the end. So we'll start from this side because the branch is closer. So we're going to name this. We're going to start it. We have carbon 2 and 4. So we're going to have 2, 4 dimethyl. We have 2 methyl. The one is in 2, the other one is in 4. And then the parent is hept, and then no double bond, no triple bond. It's going to be heptane, right? Let's do this one. This one, let's look at the parent. The longest chain of carbon, it's 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6. Or 1, 2, 3, 4, 5, 6, 7. So if we have 7 this way and we have 7 this way, right? Okay, in the previous example, let me show you this. Let's say we have a left to right and right to left. When I say left to right, I mean left to right this way, and then right to left, it's this way to this way, right? Let's look at the left to right. Let's look where our branches are located. It's in left to right, that means it's this way, right? So it's 2 and 4, right? They are located, when you go this way, they are located in 2 and 4, right? So it's 2 and 4. And then if we say we go to right to left, this is another method, guys, of confirming this name. So from this way, so it's 1, 2, 3, 4. We have at 4, 5, 6. So it's 4 and 6. So you check here the combination or the sum of these numbers. This one, 2 plus 4 is what? Is 6. And this one is what? Is 10. So you take the smallest. So you're going to name from left to right. That's what we did, from left to right. We're going to number our carbon from left to right. So it's going to 1, 2, 3, 4, 5, 6, 7. So it's left to right, right? So do you see we have 2 and 4, 2 and 4, right? Okay, fine. Let's go to this one. So the longest here is this or this. So let's take the simple one, this one. So now we have our parent, which is this one. Our stem is that one. It has 7. So we look at the ends of carbon from this side, 1, 2, 3. Do you see this is in carbon 3? And then let's look at this one from this side, 1, 2, 3. It's in carbon 3, so it's 3, 3. So they are both 3 carbons away. But now let's look at our branches. They're different. This is a what? A methyl. And this one is a what? Is an ethyl. No. This one with the 2 carbons, it's a what? It's an ethyl. And this one with the 1 carbon, it's a what? It's a methyl, right? So now, which one that comes first? The E and the M alphabetical, it's what? It's E. So we're going to consider this side of an ethyl. So it's going to be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7. Because the ethyl, we're going to consider in alphabetical order. There's an E and the M. So we're going to consider the E because they are situated in carbon 3 from both sides. 1, 2, 3, 1, 2, 3. So we're going to consider E than M. So the alphabetical order take preference. So we're going to number the carbon from this side. 2, 3, 4, 5, 6, 7. So now, even when you name, writing the name, you have a methyl and the ethyl. You start with the ethyl. Where is the ethyl? It's in carbon 3. So you say 3 ethyl. And then where is your methyl? It's in carbon 5. You're going to say 5 dash what? Methyl. Come on. 5 dash methyl. And then your parent, it's what? It's hept. No double bond, no triple bond. It's going to be heptane. I hope I do make sense. All right, let's look at the left and right and see. It's going to confirm left to right, right to left, right? Let's look at this one. So from left to right, we have 1, 2, 3. We have 3, 5, 6. No, come on. 1, 2, 3, 4, 5. So it's 3 and 5 from left to right. Our branches is 3 and 5. And then let's look from this side, right to left. 1, 2, 3, 4, 5. That's what? It's 3 and 5 as well. When it's 1, 2, 3, 4, 5. It's 3 and 5. So in this case, it proves that in any side, you can number 1, 2, 3. But now, what takes preference? It's ethyl, because alphabetical order, E comes first than M. So the side that takes preference, it's what? It's left to right. It's alphabetical order, right? E before what? M. E for ethyl. Okay, let's do the second last one, guys. Second last one. Let's look at the longest here. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. Okay. So now we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the longest is 5, which is 6. It's this. Or because it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's take the easy one. Let's take this one. Let's take this one. Right? That's the longest. So we are taking this one as our parent. So our chain, guys, here we have this end and this end, just like this one. We had this end and this end. So in this one, our chain longest starts there to there. So we have this one end and one end there. So we check, we do have branches now. We have a branch here and a branch there. They're both methyl, and this is methyl, and this is what? Methyl, right? So we check which methyl is closer to the end. As you can see, this end it's 1, 2, 3. This methyl is in 3, 1, 2. It's in 2. This one. So we're gonna start with this one. So this one is closer to this one. So number is gonna be 1, 2, 3, 4, 5, 6. Right? So we're gonna say our first methyl is in 2, second methyl is in 4. So it's 2, 4 dimethyl. And then the longest is 6, is hex and hexane, right? Let's go to the last one. We're given the name in this one. The name. So we have to draw the structure and the condense. Remember, I'm no longer doing the condense. Right? So, doing the structure here, the first thing that you need to consider is the parent. It's hapt, right? Hapt, which is it's 7. It's 7 carbons. 1, 2, 3, 4, 5, 6, 7. Right? Okay, let me just put it closer to this side. Oh, come on. Oh, come on. Yeah. It's 7. That means it's hapt. It's going to be 7 carbons, right? And then, so your first carbon can be this or it can be this. Depends on you. You want to make it for first carbon number 1, carbon 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. You have a choice on this side. So let's say, let's put it like this. This would be my carbon 1. So if this is my carbon 1, this is 1, 2, 3, 4, 5, 6, 7. So it says 3 ethyl. So in carbon 3, there's an ethyl. So 3, there's an ethyl. Remember ethyl, it's 2 carbons, right? And then in 4, there's a methyl. So in 4, there's a methyl. Methyl, that's 1 carbon there. And that's it. That's it. When you draw, this is the structural formula. Okay, remember, guys, in the test you have to put the hydrogens, but I don't because of saving time there. I hope, guys, this makes sense. Cheers. Bye.